after we have bounded the gauge and also soldered our the leads to the strain gauge, we have our specimen with the strain gauge attached to it, and also the wires here. This will allow us to connect the strain gauge into this wisdom bridge. So here's a circuit. You see that the 3 black resistors, and we connect the strain gauge to the extra arm of the wisdom bridge. Okay, so here's a circuit with 3 equal resistors to form a wisdom bridge, and on the right is the op-amp we used in our lab 3. So here you have wisdom bridge together with the amplifier, and the output is sent to the digital multimeter. So this is the diagram of the circuit is in my lecture. Okay, so here's the output from, we call this strain gauge signal conditioning unit. It's simply, its input is the resistance from the strain gauge. The output is the voltage here. So when we connect the output and turn the power on, okay, and we send the output to our digital multimeter. So right now we have not applied the load, but you see that there's a voltage read by the digital multimeter. And this is too precise. I want to make it less precise here. Okay, so it's not 0. So even though we have not applied the load, this is because the resistances in the wisdom bridge, they are not ideal. They are not perfectly matched. So we have to make small adjustments with this potentiometer. So the purpose of this one is to make fine adjustments, and we want to achieve 0 output voltage. Actually the voltage, this is extremely very good. This is very good. Okay, so now we say that now the bridge is imbalanced because corresponding to no load, the output voltage is 0. And we are almost ready to do the experiment. However, you see that we are not reading the strain, we are reading the output voltage. So for our measurement to be meaningful physically, we need to establish the relationship between the output voltage and the strain. So the way we do that is by creating a virtual strain, and here is a resistor. So we're going to put the resistor in parallel with the strain gauge. So we call this a shunt resistor, and with the strain gauge. Now we had a perfectly balanced bridge, but now you are essentially introduce some kind of virtual strain to the strain gauge. Therefore, you have an output voltage here. So this is the output voltage that we'll use later in our calculation. So once we have this information, and I also give you the resistance of the shunt resistor, we are ready to conduct our actual experiment. So I'll pause here.